We're talking about exponential functions, like exponential growth and decay and stuff. So an exponential function is just a function where basically the exponent is a variable. Okay, and we graphed those yesterday, the 1 through 12 thing. Remember, they look kind of like slides. But yeah, we're doing stuff with that today. Okay, let's make up a problem. How many kids are in your guys' class?
19.
19?
Yeah.
Okay, let's say you guys are 7th grade or 8th graders. Let's say last year in 7th grade, let's say you had 18. I don't know how many, but let's pretend that's how many you had. And actually, just to make this an easy problem, let's say you had 20, even though that's probably not true. And let's say that the size of your class increases by 5% every year. Do you guys remember how to do a 5% increase?
No, I cannot.
This was like a couple. Shh. Yeah, we multiply by, what's 5% as a decimal? 0.05. Do the decimal twice. Okay, and if I did that, I would get 1. Does that mean your class size increased by 5% is 1? What does that 1 mean?
1 person, I don't know.
21.
5% of 20 is 1. 1 would be the number that it's increased by.
Yeah.
So you could add that back to 20 and then you'd have 21. Okay. Here's another question. What happens if I multiply a number by 1? What do I get? Same number. It stays the same. What happens if I multiply a number by 1 plus 5%? Well, I get 20 times 1.05, which comes out to 21. Okay, when you multiply by 1, that gives you the 20 back. When you multiply by the extra 5%, 0.05, that gives you 1 more than that. So you get 21. So if you increase by 5% and you multiply by 1.05, that gets you, you don't have to add the 1 back to it, it's already in there. Does that make sense? Grant, let's do that later. Grant, do that later. Let's see. So instead of multiplying by 0.05 and adding it to 20, I just multiply by 1.05. That gets you up to the 21. Okay, but what if, okay, that would be an increase for 1 year, but what if it increased by 5% like for the next 4 years, like until you were seniors? Well, no, you wouldn't multiply by 4. You would want to multiply by 1.05 again and again, because that would increase it by 5% every time and again. But instead of writing it like that, you could just do it to the 4th power. Okay, that would increase 20 by 5% 4 times. Okay, this formula right here is a basic exponential growth formula. So sometimes it can look like this. I didn't put a 4 on that one. It doesn't have to be, you know. Anyway, so this number right up front here is the initial amount, like you started with 20 kids in your class or whatever. This number here is called the growth rate. It's a percentage usually, but it can be written as a decimal. This right here is like the time. How many times, like in my problem it stood for years. T stood for the years that you guys were going through school. When you simplify, when you do 1 plus the growth rate, this is the growth rate. When you simplify the parentheses and just add them together, this is called the growth factor. kind of confusing because people get these two confused. Growth rate, 5%, growth factor, 1.05. You just add the 1 to the growth rate to get the growth factor. What's a factor? A factor is a number that you multiply by. And 20 is being multiplied by 1.05 over and over and over. That's why this is a growth factor, but this is just the rate. Okay, so we have initial amount, growth rate, growth factor, and time. Okay. Let's go up here. Let me do another example. Let's say you guys, what happens to the price of a car over time? Decreases, goes down, right? So let's say in like 10 years from now, you guys buy a $10,000 car. And I'm not sure exactly, it's probably faster than this. Let's say each year that you own the car, the price drops in value by 10%. How would I find the value of the car next year? Basically, it's negative 10%. What is 10% as a decimal?
0.1.
Yeah, the decimal moves twice. You guys remember doing that? 0.1. So it's like, if we multiply by 1, it would stay 10,000. But if we drop that by 10%, what's 1 minus 0.1? 0.9. So if we just multiply by 0.9, so this is the growth rate, negative 10% basically. This is the growth factor, is 0.9. This would tell us after 1 year how much the car is worth. You guys know what that's going to come out to? $9,000.
You messed it up.
For what?
The price of the car after 1 year. Okay, but what if we want to know what's the value of the car after 2 years?
Just get rid of another car.
Well, no, because when we multiply this by 9%, what do we get? Or sorry, 90%, 0.9 is 90%. When you multiply by another 0.9, you get, 8,100. So actually this next year it only dropped $900 as opposed to $1,000. Does that make, you guys know why? Because in the first one we dropped 90% of 10,000, we dropped to 90% of 10,000, that dropped $1,000. But 90% of 9,000, or maybe saying it, we dropped this by 10%, only dropped it $900. A little bit different. Anyways, we could have done that all in one step by just putting a little 2 there, because that would just multiply by 0.9 twice. Okay, this one, when you multiply by 0.9, this number gets smaller, right? When you multiply by this number. And this would be an example of decay as opposed to growth. The first one, the class population was going up by 5%. This one was dropping by 10%. So this is actually decay. It was one of those graphs yesterday that looked like this when it goes down, down, down. I feel like I have one more question, but I forgot what it was. I remember. Okay, how do we know if this number is going to be, if this is going to get bigger or smaller over time? How do we know if the 10,000 is going to get bigger or smaller as you go? Okay, close. To be more specific, if you multiply by a number less than 1, if the growth factor is less than 1, like if you multiply by 0.9 or 0.5, that's cutting it. If you multiply by 0.5, that's cutting it in half every time. So if this number is less than 1, it's going to get smaller and smaller and smaller, decay. If it's bigger than 1, like 1.05, it's going to get bigger and bigger and bigger and bigger. Okay? That is the heart of it. That'll get us going. No. Okay, anyways. Are you guys already on page 361? You ready to go?
Yeah.
Okay, number one, here we go. It says, for each exponential function, identify the initial amount, comma. What's the, on number one, what's the initial amount? 35. Comma. Lost my place. Identify the growth rate as a percent. 5%. Do you guys see where she got that from? It said 0.05, but as a percent, that would be a 5% growth, like my first example. And then the next question is identify the growth factor. 1.05. It's basically the parentheses simplified. 1 plus 0.05 is 1.05. Okay, and then the last question is number one an example of growth or decay? Growth, because it's going up by 5%, or the growth factor is bigger than 1. That's another way to think about it. So just put growth. Whoops. Did I mention this was a tricky lesson?
Yeah.
This is one of those lessons that, like, whether you want to or not, it's going to apply to your life because interest.
What if you just like died?
Well, if you died, all your problems are over, I
That's why I
guess.
said it applies to your life, not your death.
You can just
Wait. Remember it and
go home.
This is basically, shh, guys, this is how interest works. Do you guys know what interest is?
Why have no interest?
You give money, you get money.
Yeah, okay. When you invest in, when you invest in things like, you guys have a bank account maybe?
Yeah.
That's an example. They, at the end of the year, they give you interest, extra money, just for putting your money in their bank.
That's so nice.
Money for money.
But they also, shh, be quiet. They also if you take a loan out, you have to pay them interest. And a lot more interest than you would get from giving them money. If you borrow money for like college, most of you probably will have to do that, or a house, or maybe a car someday. The bank, you're going to pay the bank interest. And this lesson kind of talks about how interest works. It doesn't just apply to money. It also, like we talked about the population of the, the class, or Bartlesville, or whatever. That's a pretty common use for it also. Some numbers, some things just go up exponentially, and some things decrease exponentially, and this just maps it out. Anyways, okay, number 3. 3 is a tricky question already. What is the initial amount? It's a trick question.
0.
No.
1. It's 1.
Why is it 1?
Because it's the same.
Yeah.
Okay, because there's no number in front of the parentheses. So what number in front of the parentheses would keep it the same?
1.
It's kind of like x is the same thing as 1x. So pretend there's an invisible 1 right there. Okay, the second question, also kind of tricky. What's the growth rate as a percent? So unlike number 1, on number 1 they put 1 plus 0.05. On number 3 they already simplified the parentheses. So what do you have to do to 1 to turn it into 7/10? How do you get a 1 to turn into a 7/10? Subtract 30% or 0.3. Yeah. So what they didn't show us, what they didn't tell us is this is kind of what must have been happening. So what is the growth rate?
30.
Negative 30%. Because it's going down instead of up. Okay, what is the growth factor?
37.
Okay, the growth factor is the parentheses 7/10. Since they already simplified the parentheses, we already have you can put a decimal or a fraction. Actually, most of this assignment I prefer if you put decimals.
No.
They're more useful in this lesson. But since they wrote it as 7/10, I'll just write it as 7/10 fraction. Okay, is number 3 an example of growth or decay?
DK.
How did you know that?
Cause it's went down.
Because it's going down 30% or because you're multiplying by a number that's less than 1? It is decay. Okay, number 5 says write each exponential function in the form f of t equals ab to the t. Okay, that looks confusing, but it's not really.
Can it just be an X?
Okay, what this means is a is the initial amount, right? B is the parentheses stuff. We're just like the 1.05, and then t is just the exponent, like normal. So it's pretty much the same as we've already been talking about. Okay, so number 5. Initial amount is 10. Where do I put that?
Before the parentheses, probably.
Right at the beginning, basically. F of t equals 10. And then it says the growth rate is 150%. Okay, 150% is 1.5, but what do I put in parentheses? No. In parentheses you put whatever 1 plus the growth rate is, right? So if the growth rate is 1.5, what's 1 plus 1.5? 2.5. So in parentheses we're going to put 2.5. So this is kind of a weird idea. What this is basically telling us is when something is increasing by 150%, it's going to be 2.5 times bigger than it was. So for example, if you guys are getting paid $30,000 in 7 years, and you got a 100% increase on that salary, do you know what that would do to your salary? Double it. 100% increase actually gives you 2 times as much. Anyways,
Wait, so we only get 30,000.
that's neither here nor there. Now, we don't know how much time is passing, so we're going to leave that as a t.
T.
If they told us how much time was passing, then we could plug it in and solve it. But they don't. Okay, number 7. Initial amount is 81, right? Yes. So where does the 81 go? Beginning. Okay. Then it says the growth rate is 1/2. What is 1/2 as a decimal? 0.5. What should I put in the parentheses right here? 1.5. And still don't know what t is. Oh, I forgot. We're supposed to say whether these are growth or decay also. Is number 5 growth or decay? Growth, because it's going up by 150%. Or we're multiplying by a number that's greater than 1. Is 7 growth or decay?
Decay.
Wait, no,
It's going up by 50%. We're multiplying by 1.5, so it is also growth.
here's what I'm gonna do.
Shh. Okay, number 9. Something changes on number 9. Can anybody spot the difference?
Different numbers.
No.
If the growth factor instead of growth.
It says growth factor instead of growth rate. You guys remember what growth factor meant?
The ending, like, you don't have to add the part.
Right, it means they already solved the parentheses for us.
That's nice.
That's what it
very
means.
nice.
So it's actually going to make this one a little bit easier. Number 9, the initial amount is 75, so put that in front. And the growth factor, not the growth rate, is 0.5.
Wait, and then always write down is like grow or decay, right?
Is that a growth or decay?
Decay.
How did you know it was decay?
Because it's plus 1.
Because we're multiplying by 0.5. So multiplying by 0.5 means it's going to be half as big as what it was every time. Okay, number 11. We're almost done with this section. Oh, never mind. We are in the next section. So on that last section, if you look at the problems, 5, 6, and 7 say growth rate. 8, 9, and 10 say growth factor. So those are different. Okay, number 11. Kind of the same thing. These are like real world problems that we're going to write an equation for. Number 11 says, this year's annual sales of $800,000 are projected to decrease by 10% each year. So we're gonna basically do the same thing we've been doing. What is the initial amount on 11? 800,000. Okay. Now the real question is what goes in parentheses. So it's supposed to decrease by 10%. So it's 1 minus what? 0.1, which equals 0.9. This was my other example from the beginning of class. And then we don't know what the time is again, so we'll just do that.
Are these gonna be on a test, like the real world, and then you have to verify?
I'm not 100% sure. You'll have to ask me when we get closer.
We're closer.
Oh, when I actually look at the test. Number 13, a culture contained 1,500 bacteria. A culture is like a little, maybe you guys learned it in science class, little petri dish where you grow bacteria in it.
It's American.
Has 1,500 bacteria that doubles in size each day. So what's my initial amount?
1,300.
Yeah, 1300.
Okay. What goes in parentheses if it's doubling each day?
3, 2.
Something
2.
Because
Oh, yeah.
If it's doubling, it's going to get twice as big each day. So it's multiplying by 2. So basically on that one, they're telling us the growth factor, not the growth rate. So we just do times 2. All right, number 15. This is where it gets kind of complicated. Some of you guys said you had bank accounts, right?
Yeah.
Have you guys? Some bank accounts. Actually, I'm not even 100% sure what my bank account does. I think mine is not simple. Some bank accounts use what they call simple interest.
well, that's all I use then, probably.
Well, you don't really choose. You just, if you go to that bank, I guess you could choose different banks that have different policies. Shh, okay. Hush. I have no idea. Boys. Okay, simple interest is kind of what we were doing up here. Like, let's say you had $1,000 in your bank account, and they told you we're going to give you 1% at the end of the year. Then you multiply by 1.01, so it'd be like $1,010. That's simple interest. Okay, compound interest is a little more complicated. It says that maybe they'll tell you we'll pay you 1% interest, but we're going to pay you 12 times a year, monthly. Okay, but here's where it gets a little tricky. If they pay you monthly, they're not going to give you that 1% every month. They're only going to give you a 12th of that 1% every month. Does that make sense? They're only going to give you a little bit of your interest in that first month, and a little bit more the second month, and then another 12th the third month. And then at the end of the year, you'll have a little bit more money than simple interest because you're going to get interest on your interest.
You're interesting. Interest.
Like after 1 month, you'll have like $1,001, and then the next month you're going to get a little more percent on not $1,000, but on $1,001. So you're going to get a little bit more interest than you would. And it also changes the formula because you're not going to get paid once per year, you're going to get paid 12 times per year. Each payment is just going to be smaller. What compound interest does is it gives you your money a little faster and it builds a little bit faster. So on this, my first example, you get like $1,010 at the end of 1 year. On this example, you probably get $1,012 or something like that. So it helps a little bit. I'm just guessing. I'd have to plug in the calculator, but that's a pretty good guess, probably. All right. Anyways, number 15 says $5,000 is invested. Actually, for 15 through 19, we don't really need the 5,000 for this question. At 6% APR. What on earth is APR? You guys probably heard that on the commercials. Stands for annual. What does annual mean?
Yearly.
Yearly, yeah, once a year.
Decade.
Percentage rate. Okay. So you're gonna get 6% per well. You probably, if you've seen like a credit card commercial, they'll say like 6% APR. That tells you how much you have to pay the credit card company. It also says that we're going to be paying for 10 years. 6% for 10 years. Okay. The first question is, if we pay annually, number 15, how many payments are we going to have to make, basically? If we're going to pay for 10 years and we're paying annually, how many payments are we going to make? Huh? 10. Not a trick question. If we're paying annually over a 10-year period, how many payments do we have to make? 10. Does that make sense?
Sure.
Okay, this is simple interest. Okay, the second question is, what percent are we going to be paying for each year? 6%. That's what this means. Okay, 15 was kind of straightforward. Actually, I'm going to help you guys be even on this one.
Yay.
Okay, 16 says semi-annually. What does that mean?
Oh my god.
What is half? Like a year?
Every other year.
Half a year. How many payments would we be paying if we paid semi-annually?
1 to 2. Oh.
How many per year? Twice a year. Twice a year. So if we paid twice a year for 10 years, how many payments are we going to make? 20. So just do 10 times 2. Okay, but listen. If we are paying twice a year, are we going to make a 6% payment every time we pay?
No, it's really 3%.
Right, it's going to be 6% divided by that 2.
Yeah.
So it's only going to be 3%. So you make more payments, but it's a smaller percentage. Okay, number 17. Quarterly. What do you think quarterly means, Grant?
Like every 3 months?
Yeah, how many times a year would that be?
4.
4. A quarter is a fourth, right? So you're making 4 payments a year for 10 years. How many payments would that be? 40.
I got more.
How much would you have to pay on that 6% per payment?
1.5%?
2. No.
6 divided by 4, 1.5%.
Yo, what's right?
Okay, Grant, that's enough. All you boys. Alright, 18. 18 says monthly. How many payments if we're paying monthly? 12. This is probably the most common. My mortgage is monthly. I'm pretty sure pretty much everybody's mortgage is monthly. That's probably the most common thing. So if you're paying 12 times a year for 10 years, how many payments would that be altogether? 120. Okay, and that 6% interest rate is going to be divided into 12. 0.5%.
I'm moving it to me. It's not that much different.
Your way better start climbing.
Oh. Yeah. Okay. Okay, I'll send them up there. Grant, what do you want?
Yeah.
actually, guys, Grant, for time's sake, we'll just go to we'll just finish this section at 19.
Let's go.
Okay,
Well, that's gonna be bad.
I forgot what oh, did you guys get this one? 0.5%. Okay, last one says daily. How many times a year are you gonna pay? You're 65. For, I don't know, they probably skipped leap year. 3,650. Payments, that's a lot of payments, but you're not gonna be paying very much, because you're gonna be paying 6% divided by 365.
Oh,
Somebody needs to plug that in the calculator. Grant, you can go.
Oh, bro.
I think you're supposed to go to elementary.
It'd be like
yeah.
one, it'd be like 1 point. Yeah.
Okay, what did it say?
So 0.6 divided by 365 is 0.00164338.
0.00? Yeah, that's right. Point, oh, hold on.
Oh, that might be wrong.
No, just 0.0, right? 0.016 is what you should have got. That's rounded off a little bit, but kinda have to. That would be a very small amount, but you have to make a lot of payments, so.
Money look like an article.
You guys, okay, I said my mortgage was monthly payments. You guys know what a mortgage is?
Yeah.
It's
where you pay off your house.
It's a loan for your house. That, yeah.
You like paid off.
If it's
your
a
house.
loan, then why don't you just call it a loan?
They just gave it a special name, probably because it's common. It's the most common loan. Probably. And if you don't pay it off, guess what happens?
They